Hello students, today in your geometry class, you're going to be working on patterns, inductive reasoning, and basic geometric drawings. So, at the end of this lesson, you should have reviewed patterns, inductive reasoning, and reviewed various different types of drawings. So below are a few different definitions that I need you to write down. The first being inductive reasoning, which is reasoning based on patterns you observe. So, as like inside out is how you should be looking at this, because we're going to look at patterns and make one big generalization of what that is. 2 is a conjecture, which is a conclusion you reach using inductive reasoning. So it's sort of like a more than just a hypothesis. Hypothesis is something you make at the beginning. A conjecture is a guess or a conclusion you reach after using inductive reasoning. Last one is counterexample. Now, a counterexample is an example that counters a previous stated example. So it proves it false. For example, if I were to say it's raining outside, your counterexample would be it couldn't be because the ground is dry. It would be your counterexample. So inductive reasoning we're going to work on in class, at least the last two. But for examples 1 and 2, see if you can figure out the pattern. We're going from 1, 3, 5, 7, 9. Hopefully you realize that we're going in just odd numbers. So the next one should be 11 and 13. So for number 2, this might be slightly more spicy. We're going from 1, 4, 9, 25. So hopefully you've noticed the pattern that it's going 1 squared, 2 squared, 3 squared, in actuality, this is slightly off. This should be 16 and then 25. So this will give us our squares. And so this will give us our 3 squared, 4 squared, and 5 squared. So obviously the next one should hopefully you'll figure out is 6 squared and 7 squared. So our answers for the next two would be 6 squared and 7 squared. The next two for camping and party we're going to do in class. Now, the next portion of what we're supposed to learn is based off of drawings. Now, isometric drawings are three-dimensional drawings such as the one here with this cylinder cut out. An orthographic drawing is based off of a three-view drawing, the front, the top, and the right view typically. And what will happen is that we take our isometric drawing and we could move it to the upper right hand corner. So engineers actually use this when they create prototypes or when they create drawings that they've created, and they push that to someone else who is going to actually manufacture it. So someone designs, someone manufactures. So when they do something like the iPhone, before they just go and build prototypes, they actually sketch it out on something similar to this, which if you're in Gateway to Technology, you'll use Autodesk Inventor, and you'll create orthographic drawings, which you can then take out and make orthographic. So what we're going to work on is, before we go on to netting, is well, we know the difference between the two. So isometric is 3D, orthographic is 3 different versions, front, top, and right. Now we're going to go into a netting. So what we do is when we spread something across a net, we're actually just taking a three-dimensional shape and flattening it out. So imagine if we were to take a box from, say, a package or something that we just bought, and we cut it up so that we can lay it down flat. Okay, so if we did that, say, for a box that had a lid or a top, and you cut that up, it would kind of look like we spread it across a hopscotch. So for this image that we have here, which is called a square pyramid, a pyramid because it's a pyramid and square because the base is a square. If you look at it, we have a square on the bottom, and then the front portion, the part that's diagonal, is a triangle. The side on the right is a triangle, the back is a triangle, and so is the left-hand side. So we have one square and 4 triangles. Now, for the last image that we're going to spread across the net, we have a cylinder. Now, look at a cylinder, or if you look at a cylinder, it's pretty easy to tell that we have 2 circles. So, it's easy to tell we have the 2 circles, one for the top and one for the bottom. So, we have those 2. Now, the next portion that we have to discuss would be the bottom. Or, sorry, the actual cylinder piece. Now, if you look at it, it's about this tall from here to here. Oh, I'm sorry, wrong shape. It's about this tall. And then, imagine if we took a Pringles bottle or a Pringles container, took up the top and bottom, and then rolled out the bottom piece, we would have the following shape. So this is how we'd spread a cylinder across a net. Okay, now it's your turn. Try solving these 2 problems and writing them on your notes. Problem number 1 says, given this isometric drawing, draw the orthographic view. For number 2, you're actually going to take this rectangular prism, which is as an isometric drawing, and draw it across a net. So for number 2, you're going to do that just like our most recent example, and for number 1, you're going to do as an orthographic drawing. So if you got what that means, it's your job to look back at the notes. That's all for now. I'll see you guys next time.